Tony.
To the chat. He's coming in hot, and he's got some very cool things to share with everyone. So, Marcus, I can talk you up a little bit, but it might be best if you just introduce yourself. I'm not sure if you guys have been on the call for a minute or so, but I'll let you introduce yourself.
All right, sure. Awesome. So, good morning, everyone. As you probably know, I'm Marcus. I'm currently based out of Singapore, which is why I was just sharing with Dennis that, it was still dark out here. So about my background, I've been in 3D printing like all along since my entire career, basically. That's the only thing I know how to do and I know what to do. I was into 3D printing since 2013. That was when, there was this initial hype of everyone's getting our own printer and we're going to print anything from our clothes hanger to my car seats and all that stuff, right? So and all along I've been in the 3D printing in the pre-sales applications role. So I started off with the more industrial style printers, as a technical geek, I think I'm fortunate enough to work with a bunch of really brilliant customers. So anyone ranging from folks who print cabin interior stuff for the aerospace.
Mm-hmm.
To researchers that's like constantly pushing the limit, pushing the boundary, trying to do everything that the OEM doesn't want them to do. So very diverse bunch of folks, and I'm very lucky and thank you for the invitation, Tony.
Oh no, absolutely, and it's awesome to have you here because I love seeing what you guys have done with your machines, but then also I think what you're saying there is so true. Like the industry has changed a lot, and like the machines and technology has changed a lot. And seeing the applications and how it's applied, to me, is the most interesting part. Like I love machines and I love seeing like motors and sensors and all this sort of stuff. But like to me, it's like how does that make an impact in the real world, and like who's using it and what problems are we solving? And I think that's like the really like kind of fun bit, that I love to see. Like and so I understand that you've got some a presentation today, right? So
yep. So
yeah, awesome.
I
so
will probably
can
need
you share
approval.
Did you want to just share your screen? I don't know if I've got to give you permission.
I think I need.
I always
I'm
make
waiting
the
for
joke that
approval
we're
to
better with
share
the
screen.
printers than we are with Zoom calls and
Right.
That's my.
But don't worry, I've got something for you that hopefully it will show up pretty well on camera.
Yeah, great. No, I'm excited.
Yeah.
I think it'll be good. I'll have the chat open, guys. So if you guys want to ask a question, I would suggest writing a message in the chat, and then we'll kind of I'll like kind of help weave it in there and whatnot. So Marcus can focus on his presentation, and then I can add your questions in, guys. So yeah.
Yeah, sure thing. Could you just give me that approval for sharing screen?
Yes.
I
Let's
need
have a look. So allow screen sharing. There you go. That would have helped you.
Yes.
There we go.
There we go. Give me a sec. Let me try to bring that right window.
Awesome.
All right. Is my screen visible?
Yeah,
for
we
everyone?
got that. Oh, yeah, that looks crystal clear to me, guys.
Right.
Yep, perfect.
Awesome. All right. Thank you. So I'm not gonna jump into our usual kind of corporate introduction. I understand that this is a part 2 of a series, and I know you guys are very interested into just the core contents. So I'm gonna jump right in. All right. I can't see you guys right now, but can I just get a feel of how many of you were in the last session that like you had some understanding on SLA, like you've heard of the term?
Yeah, so I'll have a look. I got Tyson, Liz, they were here last week. I think Kat dropped in. I think Dennis was there, and then a new a couple of newbies as well. So
Right. Okay.
yeah, maybe a high level
So
overview.
yeah, we've got a mix of folks who are
Mm,
maybe somewhat still new to this technology, right?
yeah,
So overall, I guess everyone's familiar with FDM, right? You getting your
yeah,
extrusions of your thermoplastics, and it draws the boundary of your parts, right? And with resin-based technology, basically what we call MSLA or stereolithographies, the raw materials, we started off with liquid, not this coffee, but it was liquid, right? And then we shine light on it, and wherever there's light of specific wavelength, it starts to cure. That's how it works essentially, right? And we build it up layer by layer. And if you can see from the picture, it's on the Form 4, which is our latest generation of printers. It's actually all your parts are printed upside down. So basically, it was literally like your Terminator movie. That robot just grows out of
grows out
liquid.
of the yeah.
Yeah, that's exactly what happened over there, right? So on the Form 4s, this is literally like over the years, I've played around with FDM, SLA, SLS,
Mhm.
all the polymer 3D printing technologies that you can think of, from both entry level to like industrial level printers. But Form 4 is literally by far my favorite so far, because it prints so fast
Yeah.
and all the details were just amazing, and
It's
it's
honestly
really
mind-blowing, seeing some of the parts and how quickly they print. The bit that
yeah.
got me last week is, when you figure out, "Hey, if I print one of these parts, it takes 5 hours, but if I print 10 of them all on the bed, it takes the same amount of time." So,
Absolutely,
yeah,
absolutely.
that's
And
insane
also,
to me.
as an engineer, right? I'm
Mm,
like at the beginning, I like to tinker around with the printer, like tear it down, try different settings, and then as time goes by, like I wanted to increasingly focus on the work that I do, like less on the printing side,
yeah,
or
yeah,
like I don't think anyone will
yeah,
enjoy fixing a broken printer.
totally.
So
Yeah, I mean, like,
that's
actually, Jeremy and I were having, and
yeah,
to
no,
jump
no, no
in, but
worries, no worries. Come on in. Yeah.
Jeremy and I were having this conversation yesterday because we sell a lot of FDM machines, to schools and businesses, and we were kind of chatting like, blah blah blah. Oh, should we do a slicing course, or should we do a design course? The design course is what we did first because everyone wants to like focus on what they're doing. The slicing
Mm.
course, they only need that to solve a problem, and if you solve that problem with the machine or the software, who cares about slicing, right? Like you get that
Exactly.
all built in. You just want to focus on your actual application. So when I was using the Formlabs machine and I realized you don't have to think about any of the settings, it was kind of this like wake up call. It's like, hang on, that's what every printing machine should be going towards, you know?
Absolutely. Absolutely. I mean, getting focused on what you design on, what you work on, and the problem
Mhm,
that you solve. Like fixing the settings is also a problem that you solve, but I guess we like to take it as that we will help you solve that problem so that you can focus on the real value that you're drilling into.
mhm.
Um, yeah, so that's why we were so confident about our print success rate, and we sent it out to a third party lab. So that we were very happy to see that from the lab results, we're getting 99% print success. And
Wow.
the latest printer fleet health status just came out, right? So across the last 18 months or so, when all our Phone 4s out there in the field, and so as our Phone 4 Ls, we're seeing consistently 99% print success
Wow.
across all our fleets, right? That's like tens of thousands of printers out there and abused by our customers on a daily basis, and they're still running
That's impressive. If you
printing.
said 99% in-house, I would have been like, yeah, but like experts using it and whatnot. But like you're saying 99% to anyone who's bought the machine and like you said,
Yeah.
abused it and done things with it. So wow, that's
Yeah.
impressive.
Our R&D team certainly did a great job in that.
Yeah.
aspect. And of course, right now we've got our bigger brother of the Form 4 is the larger format. So again, it inherits the same technology, same level of reliability and the details. So that's really impressive. And I guess like when we talk about an application, the problem that you solve, right? Printer and the hardware is just one component of it, right? And to me, even a bigger component would be the materials, right? What can you do if the printers are all limited by the type of material that you can offer? And that's what we really focus on. So in case that you haven't seen this, under Formlabs umbrella, in terms of just the resin side, we've got over 45 different
Wow.
resins. All of them comes with different kind of characteristics and for different needs, different applications, right? So today, that's what we're going to drill in today, and I've got a couple of samples and things that hopefully you can see clearly from the from this camera.
Yeah, yeah, definitely. I can
Yeah.
when you show them on
So,
the camera, I'll try and get your screen to enlarge. The
yeah.
one that stood out to me here was alumina. What?
Right. Right.
Real
Yeah.
alumina, right? Yeah.
That's real alumina that we're talking about, and it's one of the
Wow.
materials that's like recently is gaining quite some traction down there in Australia, especially.
Oh, wow.
That we're trying to bring like all these exotic materials
Yeah, yeah.
onto a platform that is affordable, right? Rather than if you talk about a commercial like ceramic printer that prints alumina or zirconia,
Yeah, they're not accessible, yeah.
yeah, they are north of 100,000s or
Yeah.
even more,
Mm.
right? So that's a Form X material. We're trying to be naming our materials in a pretty cool manner. But we can talk about alumina later, right? And we could start with the most basic general purpose materials. These are the materials that I'll be honest, like this will be the most popular materials by far, right? Just because they're so well rounded, they come with different colors, and these are the materials that prints most reliably, cheapest to run, and the details are just amazing. So I don't know if you guys recognize this
Yeah,
dude. He's a really cool
you
dude,
are. Mhm.
Optimum Tech from down there in Australia. And I've been trying to get hold on to this zero mouth that he designed. Could never get them because it always ran out. So basically, I highly recommend that you check out the his YouTube channel where he talk about how he got the idea of designing his own gaming mouse, and now he's running a production of that gaming mouse on our Phone 4L system, right? And the kind of detail that he was able to get from the basic. So he started off with the basic black resin, and I've got a part here that was freshly. So Tony, if you can
I'll
help to
bring this
zoom in,
here you go, here we go.
yeah,
Let's have a look into full screen. Oh, yeah, there we go.
yeah, yeah. So I've got a bunch of parts that was just printed, and this is right off that batch, right? So I hope the camera zooms in well. This will be my favorite part, right? So in like trade shows and all that,
Oh, wow, you can see the
um,
texture on it as well.
yeah, we so our teammate in the headquarters designed it really well, where we bundle in the texture on the surface
Mhm,
so that it looks and touches just like your injection molded component. And he even designed this. I hope the camera will show it better. This ejector pin mark onto
mhm,
this thing, so that whenever I hand out a printed parts and the actual parts in a trade show, right, no one can literally recognize what's the difference.
mhm,
And just in case you don't know, this is our own component. This is the mixer that runs back and forth in the build tank. And what all this thing does is that it detects the debris if there's any foreign objects in the tank while you're printing.
Mhm.
and it also constantly mix the resins so that it's homogeneous. When you're trying to print some of more exotic materials, they tend to get thicker, right? They tend to become, honey. So getting them mixed, getting them homogeneous is really important,
Mhm.
and that's what the mixer is designed for, right? And
So the
this is
parts in
actually,
the production machines are
yeah.
actually printed, or is this just for prototyping?
So that was for prototyping,
Yeah.
right? And then eventually, well, when we move into production, like, because you can imagine the amount of mixers that we sell.
Yeah, yeah.
So as the quantities scale up, it doesn't really make sense
Yeah, yeah, yeah.
for continued production with 3D printing, right? But we did run a initial test in terms of, let's say, we did run a batch of like 1,000 tests, like with the actual injection molding vendor that we commissioned this part for, right? So actually on the Form 4, it's even faster than injection mold. Right? Not to mention that it took 3 weeks to cut the mold,
Yeah.
but literally when we print like a bunch of this, right, that's easily, it's like 9 by 6. So that's 54 of
Mm.
this in I think this was around 2 hours. And we just keep on churning
Yeah,
the
yeah, yeah.
machine
Just
over and over.
so, like,
So
the volume actually for what you could get out, you could probably do quite good batch runs. I think,
yeah,
yeah, once you maybe go into the thousands or tens of thousands, then you're looking, okay, injection molding and stuff, but you could actually get a decent amount of parts out for
yeah,
that time
yeah,
frame. Yeah.
absolutely. Especially when things are becoming so much faster and so much more reliable.
Mm,
Like,
mhm.
to be honest, my camera mount right now has got this part
Yeah.
that, like, we stack things up, and you can just print everything in one go.
Jeez,
So
it's amazing. So that was all printed
yeah,
with those supports in there, and then you just pull those parts off as you need them.
yeah. So you just
Just go
unplug it like
bang.
this,
Oh,
and there you
that
go.
that was a little
Right.
easier than the FDM, supports that we are used to.
Right. Yeah, and it comes with, not just so it comes with the material itself, the printer itself, and the software behind it, right? It's a little bit
Yeah,
like what we talk about. We kind of redesign and optimize our support strategy so
yeah.
that it's constantly making it easier for folks to design the support and remove parts, just like what I did,
Mhm.
right? So that's how the zero mouth look like. Really amazing stuff. I highly recommend that you check it out. So he again started with in-house FDM as a quick, easy initial prototype, right? That fits like really well for that. And when he goes serious, when he's moving into more functional parts, then he initially started with an outsourcing of the SLS, the powder bed based technologies, and get some working samples, and quickly realized that the details and resolution that he needed wasn't there, and
Mhm.
which is why eventually he turned over to the Formlabs, just black resin, and look at how happy he is today.
Yeah. Yeah,
Right.
go check out the video, guys. It's I'll with this recording, I'll go and dig it up and chuck it in there. But the production of it, he shows the whole process. And the mouse itself, I think so it's called the zero mouse because it's meant to be
It's called a zero mouth.
like air, like it's like there's like zero mass kind of that's the idea of it. It's like approaching a negligible mass. And if you're into your gaming, that's kind of like the idea is to like just feel like you're playing like you're not moving an object kind of thing. But yeah, it's a pretty impressive and quite amazing that you can make like a consumer product with that kind of level of technology. Honestly,
Absolutely. Absolutely. All right, so that was our general purpose family. So you can do black, white, clear, which is also very popular, right? And then moving on to our engineering family. This is the so moving beyond the general purpose ones. So we've got, first of all, our tough family, and these are the materials that really meant to be tough, right? So it consists of three family members: tough 1000, 1500, and 2000. right? Each of them were simulating our thermoplastic material properties that we were kind of pretty familiar with, the high density polyethylenes, HDPEs, PP, and ABS, right? In terms of mechanical properties. So I'm just gonna play this video real quick. That's the toughest and most compliant member in the family.
Wow. Yeah, you can really see that plastic deformation. It's trying to. It's like much tougher.
Yeah. And that was probably, so this one on the left, I'm just gonna move back a little bit. So what happened here on the left was probably, if you've ever heard of resin 3D printing or SLA 3D printing, that was probably one of the perceptions that people have, right? These materials can tend to be brittle, right? Instead of our conventional plastics, which under stress or when you cut it, it doesn't really shatter, right? It slowly propagates the crack and all that. That was probably what a lot of people had in mind when plastics shatter. But on the newer tough families, we really made it behave just like our traditional thermoplastics that we were used to. Right. So I'm gonna skip the video. You can check it out on our website, on our YouTube channel. But our customers are doing really cool stuff. Sometimes pretty hardcore stuff with this material. Right. So Cool Machines they are a
900 psi.
company based out of Ohio that runs machine installation, right? And you did pick it up 900 psi. Like initially, like not a plumbing guy, I had very
I
this
just
idea of
converted it
what
to
to do.
atmospheres, and it's what 61. So the
60
pressure of
something
pressure of the
bar.
atmosphere times 61. So
Yeah.
that's a lot.
Yeah,
Yeah.
and because they're running like high pressure water hoses, right? So for it to connect that and think something that is watertight, airtight, and still withstand that kind of pressure, and most amazingly, when he frees the parts, because these are parts that will probably be operates outdoor in the winter that gets really really cold. So when he frees the part, most plastics tend to get more brittle, right? But he was able to like really torture the part and still have a part that survives.
Wow.
So I just did a real quick conversion, right? Our regular car tire was 35 psi. My bike, I pump it up to like 90 psi. And then a standard fire hose, that's about 300 psi. So just to imagine like a 3D printed resin parts, withstanding 3 times a normal fire hose that saves
Yeah.
lives.
Incredible.
That's pretty amazing.
Yeah.
Right.
Jeez. I mean, the things that you can start to make when you're not held back by those kind of limitations, especially when you add the complexity of printing. Yeah, you can. Yeah, I'm sure you've seen some really cool stuff, and it's great to see this insight of what people are using it for. Love it.
Yeah, and I guess exactly to a point. To be honest, yesterday we had an event here in Singapore, and I was preparing hands-on activities for attendees, right? And quickly I realized I didn't have enough screwdriver, so and then I have a set of those adjustable screwdrivers where I got the head, but I didn't have the handle. So what I did was basically prompt ChatGPT, hey, design for me a handle that's watertight, and I want like this grip and texture. And it came out, and then threw it onto the printer. 35 minutes later, I've got those handles, right?
So good. That's
Um,
so
when you
good.
have tools like that, like having access to the tools like that, it really opens up a lot of ideas and things that you can do.
Yeah,
Um,
definitely. Yeah. So you generated an image and then converted it to a 3D model. I'm curious what software you used to do that.
just ChatGPT, like
Wait,
I
so you got a
can,
3D model straight from ChatGPT?
yeah. So if I were to show you, sorry, I'm sidetracking a little bit.
No, sorry, I'm making you
but-
sidetrack. My apologies.
But like this, can you see my ChatGPT?
Not right now.
Hang on, let me see. Okay, that was sharing a window.
Yeah, you're sharing a window. Yeah.
Just one sec.
My apologies. I hit a button and it said I was trying to share screen. I'm not.
Oh, that's okay, Kat.
I'm just
Yeah.
trying to.
No,
I'm trying to do everything from my phone, and I'm trying to zoom in and accidentally hitting things. So please don't approve me sharing my screen. That would make no sense.
No, I didn't even see it, to be honest. All good.
Awesome. Marcus, this information is gold. Thank you so much for being here and sharing it with us. And I'm going to go back on mute again. Sorry.
Right. No worries. No worries. Thank you. And if you have any questions, feel free to jump right in. So this is how it kind of worked. Just prompt, everything was in words. And then eventually it gave me this, which obviously looks weird, right? I was telling it I want a rounder end handle and all that stuff.
And it gave you that, yeah. And then you gave it an image of a screwdriver and it got much closer. Yeah.
So this is what it got me. And it's a watertight STR file that I can just download and send it to print.
So ChatGPT actually made the STL file and it was good? Because I remember trying this like a year ago and it was terrible. Maybe I got to have another go.
Yeah, I did that a year ago. I would never do that a year ago. But lately they've really improved. Like sometimes I even throw STL files at ChatGPT and ask it to, evaluate this file for me based on best practices for SLA, SLS.
Yeah, definitely
so
would have given you a year ago. So you can evaluate for the printability and stuff like that as well. Yeah.
It will help you analyze like thin walls and all that stuff. I haven't explored enough, but that's really cool.
Love it.
All right, so coming back, let me see where that was. All right, so coming back to our tough families, right? The tough 1500 is again a material that is less compliant as compared to tough 1000, but it simulates PP material really well, right? So one of our initial beta customers, Cyrus, based out of Taiwan, they actually produce this kind of really premium suspension for electric bikes. And these electric bikes are going on for this Mint 400. That's an off-road bike racing. I was told that it was one of the toughest. So and it looks rough from the videos and the images that they share. So they essentially, so for this bike, it was like their first bike, right? So they had nothing tooled, nothing injection molded yet, and they were customizing it for this particular rider. And they needed this mud guard that protects, these, you can imagine the rocks and muds during the race from coming into their suspension, right? So these mud guards, they need to be really durable. They need to give them that premium feeling on their brand and all that. And eventually, after testing multiple different materials, they ended up with Tough 1500 that gives them that perfect balance in terms of the material properties. All right. And I've got here, actually, I want to do something violent here on camera. So I've got here my airport housing that I printed for myself, right? And that's
awesome.
how it looked like before removing the support, right? And again, I added this texture onto these parts just so that it makes them feeling more like injection molded part with textures, right? So this is the part that this is printed from Tough 1500, and you can literally like squeeze it. It's like really compliant, right? And if I were to go outside and if I were to drop it, right? So like from this height, drop it onto the floor, and you can imagine nothing will happen to this thing.
Yeah, no, that's totally fine.
Yeah. And initially, when I first printed this, I went like really, really violent. So I would literally like smash it onto the floor. I'll see if you can see this. I'll smash it onto the floor. And it's still there.
That is fine. I think you could basically step on that probably, and it'd be fine.
All right, I'll give it a try.
You're gonna give it a go.
If that's what you so
Oh, no,
can you still see me
you.
out here?
Yeah.
So I'm gonna drop it. Okay, and I'm gonna step on it. I hope you can hear it. Right? If I'm gonna be more violent,
Okay, that was a big
I'll
one.
jump on it.
Surely it's fully
Yeah.
broken.
So it did give in.
It squashed a bit.
It squashed
But
a bit.
it's still in one piece. That's insane.
It didn't break, right? And if I were to
break. Like it's breaking, but it hasn't broken.
and I can literally reform it back.
It sounded really bad. I thought it was definitely broken.
Yeah. So
that's blowing my mind. Okay, that's a thin guide. You gotta so without giving you a full engineering degree, stress equals force divided by area usually, and that part is really thin, so the area is quite small. So usually you have really large stresses building up, especially if you're gonna throw it against things. You have impact stress, which is like usually a lot higher. That part, being able to survive that, is honestly boggling my mind right now, and everything that I've like learnt in engineering. That is insane.
Yeah, I mean, without disclosing my weight, this part just went through a huge amount of stress. So yeah, I'm just saying.
Love it.
All right. So that was the top 1500, and same goes to top 2000. Again, this is the so as you progress from 1000 and 1500 to 2000, the parts gets less compliant, right? But it gets even more tougher or even more stiffer, right? And that's what, again, highly recommend that Optimum. He was so much in love with the technology that he made a few videos on this. So highly recommended to check it out. The latest generation of Zero Mouth, it weighs at about 16 grams, if I'm not wrong. And we can imagine with that kind of weight, right? And that includes the battery and all that stuff. So you really got to use minimal amount of materials, for the structural part of the mouse. And Tough 2000, works out beautifully for that, and it's again indestructible, like what you saw for this part just now.
Yeah, that's incredible. I don't know if it's in your presentation. We just got a question in the chat.
Yeah.
What the UV exposure and durability is like.
Right.
If you're going to cover it, then you can leave it, or you can do it now if you want.
Right. Yeah. Absolutely. So that's a great question, right? And it's also one of the common sort of concerns that people have on the SLA or on the resin-based technologies. And the short answer is that our all of plastics, they degrade under UV, right? Just like our air cons, like we see yellow color air cons all the time. And SLA being active or activated by light, by UV, essentially. Naturally, it's a little bit more susceptible to UVs. And in the past generations of SLA resins, that's by far a big no-no. Try to avoid resin parts from UV. Try to avoid it from sunlight. Hide it in your closet. That's what we used to joke. And again, the latest generations, especially the Tough 1500s, Tough 1000s. So like we did a UV degradation test, right? Accelerated UV test for 400 hours. And so all plastics drop, right? And when I compare it against our traditional injection molded polypropylene material, the elongation at break, right, after 400 hours, on a normal PP, it drops to about 70%, right? Wow. And when you have like a UV additive into that PP formulation, it can retain 80, sometimes even 90%, right? On a normal PP, it drops to 70%. And on the Tough 1500, they perform almost the same.
Oh, wow.
So we listed in our spec sheets on 400 hours of UV aging. So, to see that even the UV performance is catching up with the thermoplastics, it was really encouraging.
Yeah,
to see
that
that.
is like I kind of wow, the chemical engineers or whoever's formulating the stuff is doing a good job. And that's obviously a raw part, like it's exposed like to the raw print. Can
Right.
you do anything to enhance that or kind of help with that, like surface finishing and stuff like that?
Yeah, definitely. So another pretty common technique was to run, like you said, a surface finishing. So a spray of sunblocks for plastics, right? I think a lot of the perfume bottles that we used to do, we give it coatings or give it a spray that has a UV protective components to it. Um, but having said that, right, I want to set the expectations right. So these materials, although they are much more UV resistant nowadays, right, they are still like when we talk about our common general purpose resins, they can still be influenced more significantly by UV, right, and UV was one of the components. So if you're thinking about things that are outdoor that needed to survive, sunshine, rain, snow out there, a lot of our customers will switch over and turn into SLS, selective laser sintering. That's probably another topic for another day. But essentially, those plastics were nylon-based thermoplastics, and they are much, much more durable when you talk about extreme, harsh environments.
Mm-hmm. Yeah, great. Awesome. Hopefully that answers your question. Yeah, Eddie got a thumbs up. Beautiful. Love it.
All right, keep them coming. Keep them coming. Right. And so coming back to the presentations, this is really how far we've gone. So when the first generations of like tough, durable family were introduced, it was quite a step up, right? That was Form 2. It's about 9 years ago, right? When you look at the tensile modulus versus elongation and break, that's where it belonged. But there was still a bit of gap comparing to the plastics or the thermoplastics that we're used to, right? ABS, polycarbonate, polypropylene, right? And now with the release of the new generations, you can see that how far our chemists and our engineers has managed to push the envelope, right? So now these the performance, at least in terms of tensile modulus and elongation and break, they're on par, if not at a higher level than these conventional thermoplastics. Right, there are trade-offs for sure. Like right now, I'd say these resin parts, there still is a little bit of catching up to do in terms of temperature resistance, right? In terms of say for example impact resistance, but for elongation and break and tensile strength, this is by far the closest that we can get towards plastics that we are more familiar with.
And those comparisons there are to like the injection molded style
Yeah.
of that plastic. Yeah.
So
So like, if you look at FDM, you're going to be kind of on a lower kind of performance than that, I would say.
yeah, I'd say if you talk about PLA, it's probably somewhere
Mhm.
here,
Mhm.
or somewhere closer to our general purpose
Yeah.
materials, right? Now, so we have the general purpose materials in the middle, right? On the tougher end, we've got the tough family, and when you want stuff to go more rigid, to go more stiff, that's where our rigid family comes in, right? And that's where we've got two members in this family, 4,000 and Rigid 10K. In case that you're wondering, what these numbers are for, they're essentially the tensile modulus of these materials. So you can imagine it goes from 1,000 to 10,000. That's the range that we cover with our engineering families. Right. So they are perfect for applications that must resist bending and things that needs to be really stiff. And this is where it stands. So all the way we started off with Tough 1000, right, and then going all the way up to Rigid 10K. That is close to DMLS titanium
Direct
grade of.
laser sintering, is it?
Yeah.
Yeah.
So it ventured into that range of stiffness.
Yeah, in terms of
That's
stiffness. Yeah,
in terms of
that's
stiffness.
yeah, yeah.
Right. So that makes it perfect for applications like this welding jig that needed to be stiff so that your components will weld or will assemble together in this precise manner, right? And also because of the fact that it's heat resistant, right? And it's also chemically more inert than any other resins that we have. So that makes it a really popular choice for things like jigs and fixtures, things that you use in the workshop that will get constantly exposed to coolants and all the chemicals, right? And again, this is one of my favorite user story. It's again from down there in Australia, foil drive.
Making a lot of content for the Formlabs here in Australia. I love it.
So they are a long-standing customer of Formlabs, and I was really surprised when I saw that they were able to print those blades for your those motor blade propellers for your foil drive out of the Rigid 4000. So Rigid 10K was great; it was super stiff, but as many of our materials goes, or many materials goes, the stiffer it gets, the more brittle they also gets. Right. So Rigid 4000 kind of strikes a perfect balance in that space. So, they ended up printing a bunch of Rigid 4000 propellers, and they're on sale actually as in their end products.
Wow.
So that's a high level summary, right? You've got more rigid families and more brittle, and you've got tougher materials that are less rigid per se, right? And I'm just going to touch on, I want to be very mindful of the time. I just want to touch on some of the specialty materials that we offer. So essentially, we've got high temperature materials that runs, with a HTT of close to 240 degrees Celsius. And you can imagine, some big brands that I cannot mention love this high temp resins to prototype on their hair dryers. Right, it's translucent and it's high temperature resistant, so they can use it as functional parts while still observing, what goes on in there. Sometimes even the airflow in there.
Oh wow, yeah, because otherwise they're kind of running simulations and not 100% knowing. And the best way is to experiment, and this gives you that.
Yeah. And like this was probably one of the first flame retardant resins. So basically, flame retardant means that these parts or these plastics, when they catch fire, they will need to self-extinguish within a certain period, right? So the quicker that it self-extinguishes, the lower this UL94V something number will get, right? And it's critical for your, like, when you take a plane today, everything that you see, everything that you touch in the interiors, they have to be not only V0 rated, they have to be FAR Part 25 certified for flammability, and they need to pass this requirement for FST, that stands for flame, smoke, and toxicity.
Okay.
Right, so it cannot
ignite.
It cannot ignite, or it can ignite, but it must self-extinguish right within 3 seconds or so. It cannot emit smoke, because imagine when the cabin catches fire and if there is smoke,
quickly,
you loses your visibility, right? And it cannot emit toxic gas. And for resin to achieve that was really, really difficult. You can imagine those chemistries. So I've got this flame retardant part, right? That was printed on our Form 4s, and I'm gonna try something very, very dangerous. So children, if you are watching, don't try this at home. All right, I've got a torch here that I'm gonna try and burn in it, and hopefully my smoke detector will not rain on me. All right. So I'm gonna try and start. Are you ready for this?
Yeah, hold it a bit closer. It's not quite in shot right now. Yeah,
I don't want to burn my camera.
Yeah, that's fair.
But
oh my goodness.
So did you see it catching fire?
Yeah,
and the
yeah.
moment that I
Smoke,
release,
it's gone.
the
Yeah,
smoke
yeah.
is gone,
And the
right? And the
fire
smoke is
completely just comes out straight away.
yeah. All right, so that's
Wow.
how much is burned, and we're
And
safe.
that fire, that flame from that torch is hot. It is very, very hot. It's burning blue and hot. So I don't know exactly what it would get to, but yeah, that's basically the ultimate test right there.
Yeah. So that's one of the perks of working in this innovative companies. Like, just get to experience and play around with all these crazy toys.
Yeah, that'd be fun.
All right, and of course we've got ESD resins. So when you're prototyping things like that has electronics in that, you don't want static to build up and short your PCB boards. That's a perfect solution for that. And even when you're dealing things with powder, with stuff like that, right? So your air inhaler and some parts on our fuse, which obviously deals with nylon powder, we essentially prototype and run them on the ESD materials. Right? So that's what I wanted to cover for today. As you can see, we're only like halfway through of our resin portfolios. There is a large bunch of them that are medical and dental focused materials. Ultimately, I thought just give you a quick recap on who Formlabs is and where we come from. We essentially founded in year 2011, and that was actually one of the biggest Kickstarter projects in the history, and definitely in the history of 3D printing. Right?
Formlabs was started on Kickstarter. I don't even remember that. Wow.
We did, as a matter of fact.
Grew way quicker than a normal Kickstarter would.
Thank you. So it was quite legendary. There's actually this documentary that you can watch at your leisure. It's called Print the Legend. So our founder Max, I think he was still an MIT student doing his master's degree, and then he came out with this idea and this technology of bringing. Back then it was very inaccessible technology, right? Hundreds of thousands of dollars upfront, capex before you can actually see and know what it is. And he brought that SLA technology to a couple of $1,000s of price range. And I think he raised $2 million in 2012, on Kickstarter.
Wow.
And over the years, as you can see, our new product releases, it's just getting busier and busier. And we're still innovating after 12 years of history, where, like, if you've been through these 12 years, or I think by now 14 years, a lot of companies come and a lot of them has gone. And we are still here to support our customers and continue innovating. So that's a pretty nice place to be.
Yeah, definitely. And no, it's been great to partner, here at 3D Printer Gear with you guys, and the level of support, and even jumping on calls like this. We really appreciate it. And I've got a few comments in the chat saying thank you for all the information, and I think, like, having the education and showing people what you can do and that it is accessible is a really important part of that. So right.
Cool. Likewise, I mean, definitely happy to partner with 3D Printing Gears, and like having a community like this. I think that's really amazing. So I really like to stay in touch, and hopefully you don't mind me spamming the community.
No, that's fine. Spam away.
All right, so that's what I have for today. If you have any questions, I'd be more than happy to take them. Anything that you want to see, any crazy torture test that you might want me to run.
Yeah.
Feel free to go at it.
I love it. I'm just getting heaps of thank yous in the chat. That's what everyone's saying. I've got lots of thumbs up going over the screen. And
Right.
yeah, so if you guys have questions, like just unmute and go for it, or you can type it in there. Yeah, more thumbs up. Thank you, Cameron. Thank you, guys. My background in industry is I invented a glass 3D printing technology. So my curiosities were, especially when I saw the materials, was like the alumina and stuff like that. And seeing like the really hot and high temperature kind of side of it. So that aluminum material, what can it go up to? What are the what do people use it for? I mean, like, it's just, that boggles my mind that you can do that. I mean, like, some of the components that we produced, we ended up using Inconel for the high temperature kind of bits of it, but you always got degrade, what do you call it, oxidation and chemical, like it's not fully chemically inert. Whereas the alumina kind of, for me, is like already making me think, hang on a minute, I could redesign like certain parts of our high temperature extruder and maybe it be able to print borosilicate glass and stuff like that to go even higher. That's kind of like where my head's at with it all.
Right. Oh, sounds great. So in a nutshell, aluminum material, I think the maximum working temperature is 1005 degrees Celsius. So I hope that gives you sort of an idea. And it's actually a two-part process, right? So our engineers they found a way to be really innovative in printing. So we print the green parts essentially. So it has got alumina with let's call it plastic shells
in like
around
a
it.
matrix kind of thing.
Yeah. So after that, you take the green parts, put it into a sintering oven.
Gotcha.
So this oven will go through 1001 and then to 1008, if I'm not wrong.
Oh wow.
And you fire off, you burn off all the polymer components in there, and you're left with 99.99% of alumina. That's why it's called 4N, right? It's got 4 nines in there. So really, really dense, really pure alumina. I've got a sample here.
Oh yeah, that'd be great to see.
Yeah.
Wow.
So these are the alumina parts. You can still see a bit of support mark left on it, right? But if I were to knock on it, you can.
You can. Yeah, it's ceramic. Yeah, not a plastic.
Yeah, it is not plastic.
Yeah.
Right? So
that's really cool. So in the chat we got, does it still hold pressure after the sintering process? That's from Eddie. I'm gonna imagine that it's a yes, but I'll let you answer, Marcus. Because of the sintering process, you basically have a solid homogeneous part, wouldn't you?
Yeah. So you can imagine these are alumina, right? These are ceramic parts, and it, like any other ceramic parts, it doesn't hold impact really well. So if I were to drop it now, like, I would never do what I did to this guy to the alumina. But it certainly holds pressure if it's gradual and constant, and it certainly holds up the temperature really well.
Yeah. Thermal is why you're using it more. I wonder if there's a specific application that you had in mind there, Eddie, or if it's just a general kind of curiosity. But yeah, let us know. No, that's cool. And the two-part process. I mean, sometimes it's got to be like that. But if you look at how else would you make alumina parts in a cool, complicated shape? I mean, there's probably going to be some drawbacks from the sintering. Maybe you might get some more movement than you would expect in the other kind of materials. But being able to make alumina in different shapes, you just can't do that before, which is why I guess part of Formlabs' success is allowing companies to do things that they just couldn't do before. And at the end of the day, that's what the technology is really allowing people and that's why why you would go and invest into it, because you can be at the forefront of your industry, and that's saying something. And the great thing I think about it is is that, you know, being able to design, understand materials, the printing process, all of those skills are transferable. So everything you learn with FDM, you can take, you know, that understanding and apply it into the world of resin. I mean, you saw Marcus showing you guys ChatGPT, right? Like, that's to make an STL. STL can be used in any type of printing technology generally. So yeah, you kind of jump in and learn all these skills, and as the technology evolves, you keep moving with it, kind of thing. Yeah, anyway, sorry for the little spiel. Eddie was saying, I was imagining engine parts. Are there,
Right.
I'm not 100%. So how are there alumina parts in the engine? Is that part of the spark? I don't know. I'm a mechanical engineer, but I look in 3D printers more than I do in cars.
Yeah, me neither.
Yeah.
Well, it was another customer that's in automotive. They're doing EVs. So they didn't disclose what exactly they do with alumina, but they were like one of our largest
The
alumina.
electric vehicles. Yeah, if you got high voltages, I maybe alumina. Sorry, I think I hear someone. I'm getting a bit of feedback. I'm not sure who it is. It's okay. Okay, I think it's gone now. Yeah, maybe potentially it could be like an electrical thing. And yeah, but there are other materials for that. Maybe it was electrical and temperature related. I'm not sure. Yeah, EVs, maybe they're probably doing something really, really cool.
Yeah, I'm sure they do.
Yeah, awesome. Any other questions? We're basically we're almost out of time, guys. So ask them now while you can. Of course, if you do have more questions and you think of them later on, you can always message in the community at any time, and we'll let you know. If you have projects in mind that, you know, you think Formlabs would benefit and that technology would benefit from, then yes, we've got a machine at 3D Printer Gear. We've partnered with the guys here at Formlabs. So if you want to explore those avenues, you can definitely reach out and do that as well. Very, very
I've got
cool.
a quick question.
Go for it, Cameron.
First of all, thanks for hosting very valuable information here. What are some safety precautions that need to be taken with resin printing versus traditional FDM?
Right. That's a great question, and that's I guess one of the common things that people get into, right? When you see those like gooey resins, and when you have to deal with the washer solvents, those can be intimidating at first, right? So first of all, you got to take proper safety precautions, right? Wear your gloves. You don't want to get in touch with resins per se, although like when I use it on every day, like sometimes you inevitably get in touch with resins. I'm still surviving. I'm still talking, so I hope that gives you some confidence. But no, on a serious note, wear your gloves. Like follow our recommendations in terms of safety, right? And in terms of the wash solutions, again, similarly, if you're running IPA, you want to run it in a well ventilated area. And the good thing is that we have come up with our own resin wash solution. So one of the common drawback on IPA is that it's flammable, right? So when you get into like bigger corporates, or even when you run it at home, you probably wouldn't want to store like 10, 20 liters of IPA in a house. So we came out with this resin wash solution that is not flammable. So it kind of completely eliminates that concerns. And what I like the most about that is that IPA evaporates, right? And then when I'm having IPA in my wash, and I can see it slowly evaporating, and the resin level actually goes. Sorry, the solvent level goes down over time, right? And I had to constantly come back and top up. And our wash was designed in such a way that you can technically not wear a glove, just remove the build platform and hook it up to the wash. You won't get in touch with any resins, right? But for the wash to work really well, the resin level have to maintain at a certain level so that when it runs, it washes your build platform altogether for you. And if the IPA goes down, it cannot reach the surface of the build platform. And that leaves me like still something that I need to clean. And with the resin wash solution, I don't have that issue. Everything just wash out really cleanly, and it lasts twice as long as IPA.
Oh, wow.
So it doesn't evaporate; it lasts longer, and it's non-flammable.
Yeah. Oh, wow. That's pretty good. Easier to ship too. Hopefully, if it's not flammable, IPA is a nightmare to to get across borders and stuff. But so.
Yeah.
So it sounds like, I mean, we've got a few things, right? It's like evaporation and like the actual resin itself, and also the IPA, which is the isopropyl alcohol wash. But we've got the wash solution, which lower flammability, less evaporation, and all that. And then in terms of the actual process of you interacting with this stuff, I mean, you're probably going to burn yourself more on your barbecue or something like that. Like you basically don't have to get in touch with the resin. I mean, the resin itself stays in a cartridge. You tuck it in your machine. You never touch it. If you want to swap it out, you don't have to pour it out. You just swap the build chamber out, and it stays in its own little container. And then once the print's done, you take it off, put it in the wash, and you should be wearing your gloves when you do that, but you're touching a part that's not exposed to the resin. So it's a lot less messy than you think. And Cameron, if you, I can send you a link after this, but I'm not sure if you're on the other week with the live demo of it, but we showed the process of printing, washing, and curing all in one go, and that happens in our training room. Like we've got this set up in our training room, like because it's safe enough to run in a space like that now, just because you don't have to deal with touching resins, pouring it out, and the equipment is it really does keep your hands off, which is good.
Right. Yeah. Thank you for raising that. I guess like I'm so used to, or I'm so spoiled that I didn't even think about the resin pouring and like changing out tanks.
A few years
That's
ago, that was more of an issue with people getting into resins. I don't want to deal with it, it's smelly, blah blah blah. And I've been to places where they've done resin printing, and you can smell it in the walls and stuff. And it's like, hang on, you've like ruined your, it's like it's not like that
right.
anymore. It's just not like that, and it's just so clean now, which is really great.
Right. And one of the things with our raw material sourcing was that in a lot of resins that you find this really nasty chemical. It's called ACOMO, ACOMO, I think. And that's something, I'm not a chemist, but I know that that's something that I will try to stay away as much as possible. And we did our due diligence to source from reputable, high quality raw material suppliers, so that none of our resins contains alcohol in there. And those are the ones that gives you the smells, and it really kind of screw up with your nerve system. So
yeah, that's it. That's an important one too, because like I guess what we're talking about now is like impurities and stuff, right? So any material that you get, if it's PLA, PET, GABS, resins, whatever, it comes from the earth, right? Somehow, and there's a process to manufacture it. And if you have impurities, you often don't want them in there. Some are worse than others, right? Some impurities, like your PLA absorbs water when the impurity is water, but it gives off steam, right? So that's a fine impurity, for a person. Not so good for your prints, but So in terms of like quality checks, this is I guess this is important, because you don't want to be buying resins from you know, some weird listing on eBay or something because it's half the price or a third of the price because you don't know what quality checks have gone into it. And obviously, a big company like Formlabs are doing those. And you know, it's a tribute to their success and also you know, their quality machines. So yeah, thank you, Tyson. All good. Yeah, I'll have to wrap it up there, guys. Thank you so much. Thank you, Marcus. That was absolutely awesome. I learned heaps. I'm sorry if I spam you now with questions in the community, but if I have resin questions from the members, I'll shoot them your way, of course. And
absolutely,
yeah, appreciate you jumping on and sharing all of your insights with us.
No, it was definitely a great pleasure, and you guys have been an amazing bunch. So thank you for your time and all your questions. Love the energy here.
Awesome. Thank you, everyone. And yeah, we'll sign it off. As always, if you have any questions throughout the week, go for it. We've got some new courses releasing, a design course as well. And yeah, if you want more insight and maybe a specific application for Formlabs resins, you can reach out to me in the community. You can post about it. Marcus is even in the community. Sorry if you get spammed now. So you could reach out to him as well. I think yeah, I think there's a lot of ways that you can take the next step if you wanted to. So we'll leave it at that, and I'll catch you guys next time.
All right. Thanks, everyone. Have a great day.
See you guys. Bye-bye.
All right. Bye-bye.